Pluto is like a completely alien world, a frozen wasteland covered in icy floes and gigantic water ice mountains. Pluto's ocean may have life. Brian Cox is pretty confident. He believes that if our understanding of life on Earth is even remotely accurate, then there's a good chance that Pluto has its own inhabitants. When NASA's New Horizons spacecraft performed its flyby, our entire understanding of Pluto was completely changed. We came one step closer to understanding where life can thrive in the universe. The New Horizons probe made so many discoveries during its short flyby, discoveries from which we are still learning to this day. So join us as we dive deep into the depths of Pluto's ocean and uncover the secrets within, where icy landscapes, towering mountains, and mysterious activity await. Pluto's ocean may have life. One of these completely unforeseen discoveries was the potential of a subsurface ocean, an ocean that exists underneath the immense layer of ice on the surface of Pluto. And now, scientists are saying that this ocean could even have life on it, including renowned physicist Brian Cox. But how is that possible? Pluto's heart holds the answer to it. Pluto is like a completely alien world, a frozen wasteland covered in icy floes and gigantic water ice mountains. But all of this just adds on top of the mountain of evidence that there is an underground ocean on Pluto, just like Jupiter's moon, Europa. The scientists behind the mission are amazed by what they've seen. They never expected to find such thick layers of young ice, even at super-freezing temperatures. It's wild to think that this ice is thick enough to shape the landscape. The researchers were excited by the notion that Pluto could just be a rocky core surrounded by a frosty shell. And that's not all. William McKinnon, a member of the team, believes that this icy structure increases the chances of an underground ocean lurking beneath the icy surface. They've also found water ice on Pluto's mountains for the very first time. Alan Stern, the head of the New Horizons mission, is confident that there's a whole lot of water there, just waiting to be explored. But even back in 2015, there still wasn't enough evidence to confirm that Pluto does indeed have an ocean underneath. These discoveries are only clues to the puzzle. But it's been a while since then, and scientists have been hard at work uncovering the secrets of this million-dollar question. But why is everyone so obsessed with Pluto having an ocean? It's because the existence of an ocean has some pretty massive implications for Pluto, one of them being the existence of life. But even then, how can an icy cold ocean have any chance at hosting life? Brian Cox thinks Pluto could host life. Brian Cox thinks that this ocean is warm enough to have life in it. It's mind-blowing to think that this tiny dwarf planet might actually be teeming with living organisms and organic chemistry. Brian Cox is pretty confident about this idea. He believes that if our understanding of life on Earth is even remotely accurate, then there's a good chance that Pluto has its own inhabitants. But the New Horizons spacecraft might not be able to confirm the existence of warm water beneath Pluto's surface. Cox admits that it's a bit challenging to gather concrete evidence about this mysterious ocean. He suggests that we should instead focus our efforts on exploring the moons of other planets closer to home. Europa, a moon of Jupiter, and some of Saturn's moons like Titan and Enceladus are more promising in terms of finding clues about extraterrestrial life. Cox points out that Titan seems to have a subsurface ocean, and Enceladus even shoots out liquid into space. We could fly through that and check for organics. So while the possibility of Pluto's hidden ocean is fascinating, it seems like our best chances of finding evidence of life lie closer to home, among the moons of other planets. According to Brian Cox, getting from single-celled organisms to complex multicellular creatures is like squeezing through a super-tight bottleneck. It's so tough that only a small fraction of planets where life exists will actually have anything beyond simple biology. Cox thinks that complex life is probably a rare occurrence in the universe. But he also points out something interesting about our discoveries so far. Everywhere we find liquid water on Earth, we also find life. And since our solar system is made up of similar stuff, it makes sense to think that life could exist in the liquid water on Pluto, too. But Cox insists on tempering expectations. As we're not talking about big, technologically advanced creatures here, if there is life on Pluto, it would likely be very basic and uncomplicated. Even though complex life is rare, any sign of alien life, no matter how simple, would be absolutely mind-blowing. At the end of the day, scientists believe that the probability of Pluto hosting life could be pretty high, as there is still much to learn about this dwarf planet. Pluto has a heart. The key to life on Pluto lies in its heart. NASA discovered that Pluto has a special feature they call a heart, and it's driving a lot of action on the planet. This heart is a gigantic nitrogen glacier that covers a staggering 1,000,000 square miles. But there is this one location within the heart, known as Sputnik Planitia. It is the largest glacier in the solar system. Initially, astronomers believed that this distinctive feature formed as a result of a powerful collision with another large object in Pluto's past. However, the odd location of this basin raises questions. It is situated precisely on the opposite side of Pluto from its prominent moon, Charon. The chances of an impact occurring in such a specific location directly opposite Charon may be too slim to call it a mere coincidence. Instead, scientists propose that the alignment between Charon and Sputnik Planitia could be the result of polar wander. Basically, it's when a planet shifts its spin axis because of major geological processes. Sputnik Planitia ended up in its current position because it's like a trap for cold temperatures. Nitrogen ice has piled up there, forming a massive ice sheet that's at least 2.5 miles thick. And this phenomenon can only occur if Pluto possesses an ocean beneath its icy surface. This basin made Pluto completely change its orientation so that it faces directly opposite its moon, Charon. The interesting thing is that the heavy weight of this ice, combined with the gravitational pulls from Charon, caused Pluto to tilt and align the basin more closely with the gravitational axis between Pluto and Charon. This shift probably caused the surface of Pluto to crack and created those enormous faults that zigzag across the planet. The basin originally formed to the northwest, closer to Pluto's north pole. And if more ice continues to accumulate in the basin, Pluto will keep changing its orientation. These discoveries shed light on the dynamic nature of even the most distant and mysterious objects in our solar system. But there is still a lot of mystery surrounding Sputnik Planitia. The mystery of Sputnik Planitia. Brian Cox referred to this area as Tombaugh Regio, but it's more commonly known as Pluto's heart. And right on the edge of this region, there's a range of mountains made entirely of frozen water ice that towers up to 6 kilometers above the surrounding plain. But what makes this area even more peculiar is that it stands out from the rest of the dwarf planet. Dr. Cox explained that the surface of Pluto is covered in craters from countless impacts that happened over billions of years. But something is different about Sputnik Planitia. It's incredibly smooth, without a single crater in sight. It's really intriguing how this part of Pluto breaks the pattern and sets itself apart from the rest of the world. If you zoom in on the surface of Sputnik Planitia, you'll be amazed by something completely unique in our solar system. There's a fascinating network of polygonal shapes etched into the icy surface, each one spanning at least 10 kilometers. They look a bit like cells seen through a microscope, but they're not. These shapes actually provide evidence of Pluto's internal heat desperately trying to escape from beneath the glacier. As a result, bubbles of upwelling and downwelling nitrogen ice form, creating a mesmerizing effect similar to a lava lamp. What's really intriguing is that these formations are unlike anything we've seen in Earth's glaciers or anywhere else in the solar system we've explored. From a distance, the absence of craters on Pluto is striking, but as we get closer, the mystery deepens. The detailed images captured by New Horizons show an intricate pattern of hexagons and pentagons crisscrossing the frozen nitrogen surface. It's a clue that nature might hold similar patterns elsewhere, yet this peculiar phenomenon remains truly extraordinary. Dr. Cox explained that the peculiar patterns observed on Pluto's surface are indicative of convection, a process driven by a heat source. This heat source causes the material, in this case nitrogen ice, to rise, cool down, and then descend once again. As a result, the currents constantly rejuvenate the area, creating these distinct patterns. The fact that a small world like Pluto is still active came as a tremendous surprise. But where is this heat coming from? This phenomenon is explained by a theory that suggests that there are radioactive elements deep within Pluto's interior. As these elements decay, they generate heat, which could be responsible for melting the nitrogen ice, causing it to rise and fall. This ongoing activity suggests that Pluto is far more dynamic than previously imagined. This discovery is another clue that there might be a concealed ocean of water below Pluto's surface. But can we be absolutely certain that Pluto possesses an ocean? Well, the gathered evidence suggests that there could indeed be more to the story. New Horizons data revealed something intriguing about Sputnik Planitia, the presence of a heavier mass beneath it that likely played a role in its reorientation. Scientists suspect that this weightier mass could be a water ocean. Multiple lines of evidence support this notion, including the tectonic features observed in the images captured by New Horizons. These features indicate the presence of an ocean beneath Pluto's crust. Sputnik Planitia is believed to have formed around 4 billion years ago, and was likely shaped by a colossal impact from a Kuiper Belt object measuring 50 to 100 kilometers across. This impact created a massive cavity in Pluto's icy crust, leaving only a thin and fragile layer on the basin's floor. Subsequently, a subsurface ocean would have filled up this cavity and exerted pressure on the weakened crust. Over time, the nitrogen ice layer that we now see on the surface was deposited on top. Models, based on the planet's images, propose that this liquid ocean may have emerged through a rapid formation process. While it is not an absolute confirmation, these findings strongly suggest the presence of an ocean within Pluto. The truth behind Pluto's ocean. Did you know that astronomers used to think Pluto formed slowly from cold materials? They believed that as debris swirled around the sun, the dwarf planet gradually accumulated bits of rock and ice. Over time, its internal heat would have melted some of the ice, giving rise to an underground ocean. This explanation seemed logical, as the presence of radioactive elements could account for the warmth needed to maintain the ocean. However, a study published in June 2020 decided to put this theory to the test. The researchers wanted to explore the possibility that Pluto actually began in a hot state, formed through a series of massive collisions similar to Earth's early history. The fascinating outcome of this research suggests that Pluto's hidden liquid ocean has likely endured for billions of years. This finding implies that subsurface oceans might be widespread in the outer regions of our solar system, sparking excitement among those interested in discovering extraterrestrial life. While Earth was still a seething mass of molten magma, Pluto and its subterranean ocean were taking shape. Ever since then, this distant world has harbored liquid water, potentially creating a habitat suitable for life. The study took a fresh look at Pluto's formation by comparing computer models with data collected by the New Horizons mission. Surprisingly, it proposes that Pluto was actually quite hot during its early days and possessed a subsurface ocean. This groundbreaking research challenges previous scientific theories about Pluto's origins. It also suggests that liquid oceans once believed to be exclusive to Earth are widespread among dwarf planets throughout the outer reaches of our solar system. According to Alan Stern, an astronomer leading NASA's New Horizons mission, these findings have significant implications. If oceans are not rare occurrences, but rather a common feature in the outer solar system, then this changes everything. This revelation has sparked excitement as it expands our understanding of the potential for life in various celestial bodies. Stern says that it's a game changer on how we view the solar system. Back in 2015, when the New Horizons spacecraft flew past Pluto, scientists were astonished by the vibrant and intricate geology on its surface. They started suspecting that there might be an ocean hidden deep beneath the icy crust, and over time, those suspicions have grown stronger. Today, most planetary scientists are in agreement that Pluto does indeed possess a global liquid ocean. Carver Beerson, a graduate student at the University of California, Santa Cruz, and the lead author of the study, explains that our understanding of the inner solar system is quite solid thanks to meteorites and other sources of information. However, when it comes to the outer solar system where Pluto resides, our knowledge is relatively limited. This study aims to fill in some of those gaps and provide a clearer picture of what's happening out there. So did Pluto have a cold start or a hot start? And how do we even figure it out? This study holds the answer to that question. Cold start or hot start? It turns out there's a clever way to figure out whether Pluto formed hot or cold just by looking at its surface. It's all about how water behaves when it freezes and melts. Stern compares this to putting a glass of water in the freezer. You'll be left with a crack in the glass overnight. That's because when water freezes, it expands. The same thing happens on Pluto. When water turns into ice, the molecules inside slow down and arrange themselves into a crystal structure, causing the ice to become less dense. That's why ice cubes float in your drink, and why frozen water takes up more space. So if Pluto started off hot and gradually froze, its surface should have expanded, leaving behind signs of geological features formed through expansion. On the other hand, if Pluto began in a cold state, its surface would show evidence of compression over the course of its ancient history. To investigate which scenario fits the evidence, the team closely examined the data from the New Horizons mission. They were surprised by what they discovered. They saw areas on Pluto that appear to be very old as the solar system itself, and they didn't see any signs of compression, according to Carver Beerson, another researcher involved in the study. This suggests that Pluto had a hot start. Let us give you an example that supports the idea of Pluto having a hot start. When we look at craters on icy worlds, we usually see them as neat circles formed by impacts. However, on Pluto, the craters have been stretched out over time, even in the oldest areas. Strangely enough, none of them show signs of compression. There are other pieces of evidence as well. Carver Beerson created a model of Pluto's early formation using a hot start scenario. He discovered that if Pluto formed through a series of big impacts happening one after another, the heat generated by those explosions would have kept the internal ocean in a liquid state. However, for this to happen, Pluto would have had to form within a very short period of time, around 30,000 years or even less. Interestingly, this idea aligns with recent models of how the Kuiper Belt, a region beyond Neptune with icy objects and dwarf planets, evolved in its early stages. More research points towards the fact that small objects in the Kuiper Belt formed in a short amount of time, roughly a few hundred or thousand years. Beerson says that it's quite fascinating that the geology is pointing us in this direction. Researchers studying the dynamics of the Kuiper Belt are also reaching similar conclusions. He adds that the notion of a hot start for Pluto is a surprising and unconventional answer. Pluto's speculated fiery beginning has significant implications not just for Pluto itself, but also for its neighboring dwarf planets like Eris, Makemake, and Haumea. If Pluto formed hot and fast, it's likely that other dwarf planets did too. This new understanding, combined with our knowledge of the icy ocean moons around the gas giants, challenges the old belief that Earth is the only ocean world in our solar system. Surprisingly, the outer reaches of our solar system may be teeming with liquid water. According to Stern, there could be dozens of worlds in both the inner and outer solar systems with oceans. This is considered one of the most remarkable discoveries in planetary science during the space age. These alien worlds may not appear like they're capable of giving birth to life at first glance. After all, Pluto is about 4 billion miles away from the Sun, meaning it gets very little light, which causes surface temperatures to plummet to around minus 400 degrees Fahrenheit, or 33 Kelvin. However, beneath Pluto's icy exterior, in the relatively warmer subsurface ocean, life could find refuge from radiation and asteroid impacts. Stern explains how this could be safer for life. The intriguing thing about oceans beneath the surface is that in many ways, they offer safer havens for life. You're shielded from cataclysmic events like the asteroid impact that wiped out the dinosaurs. If the sun releases solar flares or a supernova occurs, you would be protected from those hazards. The latest discovery adds to the growing body of evidence pointing towards Pluto's long-standing presence of an active ocean. The head of the New Horizons mission acknowledges that the evidence they have for Pluto's ocean is not direct. He compares it to circumstantial evidence in a court of law, which may not be enough for a conviction. That's why he and a team of researchers are advocating for a Pluto orbiter that would not only revisit the dwarf planet, but also enter into orbit around it. The New Horizons spacecraft only provided a brief glimpse of Pluto during its flyby, capturing high-quality images of only 40% of the distant world. It's a wonder that we've gotten so much information from a short flyby. Furthermore, 40% of the surface was too dark for New Horizons to observe anything at all. In contrast, A Pluto orbiter could be equipped with radar and laser instruments capable of sensing the surface without relying on visible light. Stern emphasizes the need for an orbiter to definitively confirm the existence of Pluto's ocean, drawing parallels to the missions of Cassini, which confirmed the presence of an ocean on Enceladus, and Galileo, which established the existence of an ocean on Europa. This is where Persephone mission comes in. New orbiter Persephone. What is the Persephone mission? Persephone is a concept mission study that aims to answer the questions the New Horizons mission brought up. It is true that while we did gain a lot of insight into Kuiper Belt objects and Pluto from the New Horizons mission, it raised a lot more questions than it answered. Important questions like the internal structures of Pluto and Charon, and the evolution of Kuiper Belt objects and Pluto itself. But the most important question of all is whether or not Pluto really has an ocean. To unravel these mysteries, the Persephone mission will carry an extensive payload and employ a dual approach. It will orbit within the Pluto system while also planning encounters with other KBOs, ensuring a comprehensive study of these celestial bodies. But how long will it take to reach Pluto? Roughly 27.6 years, even when using a gravity assist from Jupiter. While the full mission will last a total of 30.7 years, as it'll tour Pluto for 3 more years until it moves on to Kuiper Belt objects. Reaching Pluto is no easy feat, as demonstrated by the New Horizons mission. It took them 9.5 years from 2006 to 2015 just to fly by Pluto. However, a mission like Persephone that aims to enter orbit around Pluto and its moons would take over 27 years. The reason for this extended timeline is the challenge of achieving orbit. Dr. Carly Howitt, the principal investigator of the Persephone mission concept, explains the difficulty involved. She says that getting a mission into the Pluto system and orbiting it is a daunting task because Pluto is incredibly far away. In order to enter orbit, the spacecraft must approach slowly, which means a lengthy cruise time. On the other hand, if the spacecraft travels faster, it would reach there sooner, but it'll require a lot of fuel to slow itself down so it doesn't whip past Pluto, making the mission larger and more expensive. Additionally, a more advanced power source is necessary because current generators won't last for over 30 years. Whether the mission takes 18 or 27 years, the journey to Pluto includes a significant amount of time. We're talking about a journey that spans an entire childhood, without even considering the time for development and operations. Howitt explains that despite the lengthy duration, the mission is still worthwhile and worth pursuing. The New Horizons mission unveiled the fascinating and diverse nature of objects in the Kuiper Belt, raising numerous unanswered questions. To address these questions and explore the region within the next 50 years, we need to select a mission promptly, because the journey to these faraway worlds takes many decades. The Persephone mission could be the answer we're looking for. Now, let's talk about the cost. Persephone would require over $3 billion of NASA's budget. With such a significant investment, it's essential to ensure that the mission is truly worthwhile. Although the New Horizons mission provided us with the best close-up view of Pluto to date, it was merely a snapshot in time. Consequently, the data it obtained has some limitations, particularly when it comes to describing the surface changes, atmospheric dynamics, and the history of volatiles on Pluto. Persephone, on the other hand, presents a unique opportunity to observe temporal changes in the Pluto system. It can capture both short-term changes occurring during its 3 Earth-year tour and long-term changes spanning 43 Earth years since the New Horizons flyby. However, it's important to acknowledge that this mission carries some risks. Its success depends on the advancement of key technologies. There are 2 main risks associated with the Persephone mission: power and the launch vehicle. Currently, they need 5 radioisotope thermoelectric generators, or RTGs, but this number might increase if more power is required. Additionally, if the SLS or the Space Launch Vehicle doesn't perform as expected, they might need to make modifications to reduce the total mass of the mission. However, despite these risks, the potential rewards make it all worthwhile. If astronomers' suspicions about Pluto having a subsurface ocean are correct, then it opens up exciting possibilities. Not only could there be another place where life could exist in our own solar system, but it could also mean that there's another type of planet out there in the vast universe where life could thrive. Understanding why Pluto remains active despite its distance from the Sun and why it has liquid water are the key questions that Persephone aims to answer. How it says that to unravel these mysteries, we need to go into orbit around Pluto because a single flyby doesn't provide enough information. By orbiting Pluto, we can study its gravity signature and observe how it influences the spacecraft repeatedly over time. New Horizons has been incredibly important, but despite only observing Pluto for a short and brief amount of time, the New Horizons mission has allowed us to raise these questions in the first place. The journey of the spacecraft toward Pluto began on January 15, 2015. On March 10th, its trajectory was adjusted with a thruster burn. 2 days later, it reached a point where it was closer to Pluto than Earth is to the Sun, with about 4 months remaining until the close encounter. As April 29, 2015 approached, pictures of Pluto started revealing distinct features. Each passing week brought more detail as the spacecraft approached. On June 29, 2015, a final engine burn accelerated New Horizons and refined its path toward the target. But the mission almost turned to the worst on July 4, 2015. New Horizons went into safe mode due to a timing error in the spacecraft's command sequence. The team had to sit in constant worry and concern for several days until July 7th, where the spacecraft returned to normal operations after 3 days. After another 3 days, data from New Horizons provided a conclusive answer to one of Pluto's fundamental mysteries, its size. Scientists determined that Pluto has a diameter of about 2,370 kilometers, slightly larger than previous estimates. The Moon, Charon, was also measured to be around 1,208 kilometers in diameter. Then, on July 14th, New Horizons flew approximately 7,800 kilometers above Pluto's surface. Confirmation of a successful flyby came 13 hours later, when a series of status messages were received at mission operations. The mission was extended for a second time, potentially allowing for multidisciplinary observations relevant to the solar system and NASA's heliophysics and astrophysics divisions. Currently, the probe is in good health inside the Kuiper Belt. It's moving away from the center of our solar system at a pace of 300 million miles per year. It entered hibernation mode. This was to conserve fuel and reduce wear and tear. What did they find? The mission no doubt changed scientists' assumptions about Pluto. It turns out some of our guesses about Pluto were not as accurate. After a decade of traveling over 3 billion miles, the probe come close to Pluto, giving it a chance to provide humanity with the most detailed view of its surface to date. And it wasn't just Pluto that was examined. NASA also got a good look at Charon. But this flyby marked the end of NASA's long exploration of the planets, which started 50 years ago with Mariner 2. Scientists were particularly astonished by the level of ongoing activity on Pluto's surface. The presence of atmospheric haze and an atmospheric escape rate lower than predicted forced a significant re-evaluation of previous models of the Pluto system. The New Horizons team dedicated 15 years to plan and execute this flyby, and Pluto exceeded their expectations. So despite taking so much time and effort, Pluto was worth the trouble. Now, scientists understand that despite its frigid location, Pluto is a dynamic, lively, and scientifically significant world. Astonishingly, it even holds clues that can enhance our understanding of other small planets situated in the outermost reaches of our solar system. But while New Horizons completed its mission of examining Pluto and a KBO known as Arakoth in 2019, what else is left for this probe? The focus might shift away from Kuiper Belt objects. NASA is unsure of what to do with its New Horizons probe. They're trying to figure out whether to stick with the probe's original mission or embark on a different scientific endeavor.
Thanks for watching. Show your support by subscribing, ringing the bell, and enabling notifications.